Let's talk about Project 2, Day 1, which corresponds for Lesson 6 of Algebra 2B. So today I am going to take you through a couple hints for each of the questions for this first section of Project 2. I'm going to model quite a few problems. I am not going to be modeling your actual project questions because that would just be doing the project for you, right? But I am going to work out and model similar problems that will hopefully give you an idea or a better idea of how to go about solving your problems. My modeled questions or my modeled equations will not be completely identical in procedure to what you have to do, so don't assume that you can follow step for step the way I solve my own example to what you have to do. Okay, it's going to be roughly the same kind of ballpark type of thing, but again, you'll still have to kind of intuit and problem solve on your own in order to arrive at the correct answer for your project questions. That being said, let's get started. So, as usual, I am not representing all of the text, all of the context for your problems here, so please make sure you've already tried or at least read through the first section of the project, otherwise this might not make a ton of sense. Let's get started with question 1. So it says the first spell the Plaid Wizard would like you to undo is the Luke, I am your father spell. This spell follows the pattern, and it says square the x, multiply by 3, add 8, and 18x divide by 5, all to get y. This results in the formula y equals the quantity 3x squared plus 18x plus 8 divided by 5. And in order to undo this spell, we have to first rewrite the formula in vertex form. Which option does this correctly? So quite a bit of wording there. Essentially, they're saying here is your formula, rewrite it in vertex form. Okay? So if nothing else, take that formula, rewrite it in vertex form. Now the actual spell part is worth noticing. It'll come into play later. But notice that we had an x, right? And then they said square the x and multiply it by 3. That's how we got 3x squared. We added 18x and 8. And that became our numerator because after that it said divide by 5. So we divided everything by 5. And it said all to get y. And that's how we set this equal to y. Okay? And now we need to take what we have here and rewrite in vertex form. So vertex form looks like this. It's of the form y equals a times the quantity x minus h squared plus k. Now hopefully you remember kind of our standard sort of quadratic form. I won't even write the y. We'll have like an ax squared plus bx plus c, right? So you know that a, b, and c are coefficients. A is the coefficient that corresponds to the x squared term, b is the coefficient that corresponds to the x term, and c is our constant. So the a that you see here is the same a that you see here. Now you see also this h and k, and you're probably wondering, all right, well, I'm used to a, b, and c. What is this h and k? Well, hk refers to the vertex itself. And I won't go a ton into this because this was kind of reviewed in the lesson. But hk is going to be the coordinate of your vertex. So if I had some parabola that looked like this, and this was my vertex, hk gives me the x and the y coordinates of the vertex, okay? Now notice, so I've got this line here, but notice that it's broken down even further, and it even tells you how to get h, how to get k. So to get h, we take negative b divided by 2a. All right? To get k, we take b squared divided by 4a. So, while initially this may have looked sort of confusing, notice this is almost like a plug and chug sort of question. Now, it is complicated because, we're dealing with a fraction. So complicated due to the numbers that we're using in this situation. We're going to have to call on our knowledge of manipulating fractions. All right? But other than that, the actual steps we need to do are straightforward. It's just keeping our information straight. And so let me show you what I mean. So this is not the same equation that you were given in the last slide. Okay, this is just one I made up off the top of my head, and I'm going to show you, I'm pretending that I was given the same question but with this equation, and I'm going to solve it for you to demonstrate one way I could go about putting something in vertex form. So as I was saying in the last slide, one thing I can do is just sort of, I've got this format here. I can match up the pieces of that format to this one, okay, to kind of figure out how to get this in vertex form. So the best way to show you what I mean is just to demonstrate it. So my final vertex form will look like this. Y equals, and I'm going to kind of color coordinate here, y equals A. I can see that A is equal to 2, right? So I've got y equals, 2/5. So in fact, to avoid confusion there, let's rewrite that because I almost even just made that mistake. So let's rewrite this and separate out our fractions. So rather than having everything over 5, I'm just going to rewrite this as 2/5 x squared plus 4/5 x plus 10. Okay, so again, notice that this is equivalent. It's an equivalent statement. I've just rewritten it. I've broken up my terms into individual pieces rather than having everything over a denominator. And that's going to stop me from making that mistake that I almost just made. Okay, so A is going to be 2/5, right? So going back to my pen, the first thing I need to do is write down A, if I can get to the right, there we go. So y equals 2/5 times the quantity x minus, and it's going to be a negative b over 2 times a, the quantity squared. So what I'm doing right now is just kind of writing out the skeleton of the problem, all right? So I'm not filling in my a's and b's yet. I'm just writing out the skeleton of the problem. So then I'll have c minus, and then I'm going to have a fraction over here. All right, so you'll see what I mean in a moment here. So the next thing I'm going to do is fill in b. So b corresponds to my x term. It's the coefficient for my x term. So b is going to be 4/5. All right, b is 4/5. So changing colors here. So negative b would be just negative 4/5. All right, and then I've got b again over here. I'm just going to write that now. 4/5. Notice that it's b squared, which means I'm going to take this whole fraction and square it. Okay. Next, I'm going to fill in c. Let's do that next. So c is just equal to 10. That's easy enough. So going back to my pen, takes me a while here. C appears right here. Now I have to finish. I didn't quite fill in all of my a's, so I have to go back to that color. So a was equal to 2/5. So notice that this denominator is 2a, or 2 times 2/5. And then I have another a over here, 4a, or 4 times 2/5. All right, so this is a pretty ugly setup, right? I definitely need to simplify this if I want to proceed. This is not a helpful format. So I'm going to work on simplifying this, and I'm just going to draw a line here. I think what I'm going to do is do some scratch work on the right-hand side and kind of work on just rewriting it as I go on the left-hand side. So let's see what we can do. So y equals 2/5, that's fine as it is, times the quantity x minus, all right, let's work on simplifying that fraction. This one right here. So I've got negative 4/5, right, negative b, so negative 4/5 divided by 2 times 2/5. And I'm going to go slow here. It's really easy to make mistakes, so I just want to double check everything I'm doing as I go. So once more, negative b, so I've got negative 4/5 divided by 2 times a. A is 2/5. All right, that looks good. So I can start simplifying. So the first thing I'm going to do, notice that I can simplify the denominator. So 2, which is the same thing as 2 over 1, 2 times 2/5 is just equal to 4/5, right? So I've got negative 4/5. Again, just double checking. Negative 4/5 divided by 4/5. Negative 4/5 divided by 4/5. All right, so let's see here. I am going to do the keep, change, flip method. And again, you'll notice me kind of pausing it here and there. Again, I'm just trying to go slow to make sure I haven't made any mistakes. All right, so, and I'm just rewriting this over here. So I've got negative 4/5, which is my negative b. I'm going to change the sign, and I'm going to flip the denominator, and that's how I do fraction division. Now, if this looks weird, if you don't remember it, you might want to Google fraction division or keep, change, flip. All right, so now I'm going to simplify. Notice that I can simplify, these 5's cancel out and become 1, this 4, and this negative 4 cancels out, this becomes a negative 1. So when all is said and done, this whole fraction, that whole ugly fraction, simplified quite easily to negative 1. So I'm just going to write in negative 1. All right, so moving forward, I get plus 10 minus, and then I've got kind of another hairy fraction. So let's work on that one next. So I've got 4, and I'm just rewriting this fraction. 4/5 squared divided by, and the denominator is 4 times 2/5. Well, 4 times 2 is 8, so I'm just going to simplify that right away. 8/5. All right. To save space, I'm going to combine two steps here. Once again, we're going to be doing keep, change, flip. Notice that this square applies to my whole fraction, right? So 4, let me change colors so we can see. 4 squared is 16, right? 5 squared is 25. So I'm going to keep this. I'm going to change the division into multiplication, and I'm going to flip my denominator to 5/8. Now I can simplify. So 25 and 5 cancel out. 16 and 8 cancel out. So I'm left with just 2/5. Okay. Now I can keep simplifying, and I'm just going to go down to one color here. So I've got y equals 2/5 times x minus a negative 1 is positive 1 squared plus 10 minus 2/5. All right, so 10, I'm going to rewrite 10 as a fraction with 5 as the denominator. So how many fifths would 10/5 be? Well, 10 is the same thing as 50 over 5, right? 10 is 50/5. 50 minus 2 is 48, so 48/5. So I have this now written in vertex form. So notice I can kind of match up each piece. I've got y equals 2/5, which was the same thing as a, right? It was the same thing as a, times the quantity x minus, now the reason that I have a plus is because I rewrote my negative term. If you had wanted to leave it in that form, x minus a negative 1, that would have been okay, all right? Squared plus 48 over 5, plus 48 over 5, all right? So hopefully that gave you an idea of how you can go about manipulating yours the same way. I would say if you're doing it by hand, definitely color coordinate if possible, the way I did. Give yourself a lot of room, the same way that I just did all my scratch work on the right-hand side, but I was able to keep things kind of cleaner on the left-hand side. So that would be my answer, that y equals 2/5 times the quantity x plus 1 squared plus 48 over 5. That is my equation in vertex form, and now we are ready to keep going. All right, so now it says to finish undoing the spell, I need to isolate x. I need to isolate x, and it says which option does this correctly. So once again, I can't show you how to isolate x on your specific one. That would just be kind of giving you away the answer, and then again, it's not a fair way to do it, because then you don't have the opportunity to learn anything. So instead, once again, I'm using my made-up example. So you'll have something in this exact same form, right? You're going to have, and it might even look nicer than mine. Notice that I ended up with kind of an ugly fraction at the end there. Hopefully you won't. But my expression is y equals 2/5 times the quantity x minus 5 squared plus 48 over 5. And I need to isolate x. All right, so how am I going to go about doing this? Well, the first thing I notice is that it'd be pretty easy, so remembering that x is my goal here, it's going to be pretty easy for me to get rid of this 48 over 5, right? If I just subtract 48 over 5 from both sides of the equation. So let's do that, and I'll rewrite. So now I've got y minus 48 over 5 equals 2/5 x minus 5 squared. What can I do next? All right, so again, keeping in mind that my goal is to isolate x, the next thing I could do is divide both sides of the equation by 2/5, right? And I'm going to, remember, you have to divide each piece of the left-hand side, or each term that appears, by the same number to keep everything equivalent, okay? So since I'm dividing the right-hand side, which is all one connected term, by 2/5, I also have to divide y by 2/5. I also have to divide 48 over 5 by 2/5, okay? All right, so let's rewrite and simplify. So if I have y, and I'm just going to do some scratch work on the right-hand side, if I have y divided by 2/5, that's the same thing as y over 1 divided by 2/5, right? So I'm going to use my keep, change, flip method. I'm going to keep y over 1 as it is. I'm going to change division to multiplication, and I'm going to flip my second number. Now I can simplify, and I can see that this is the same thing as multiplying my denominators and my numerators, 5 halves times y. So I can write this as 5/2 y or 5y over 2. Alright, these are the same thing. I prefer the look of this way of writing it. If you prefer writing it that way, that's totally fine. So I'm going to rewrite this as 5 over 2 times y minus, alright, now I got to figure out my next one. So I had 48 over 5 divided by 2 over 5. Okay, once again, I'm going to do my keep, change, flip method, and just to save space, I'm going to do that right there. So I'm going to keep 48 over 5. I'm going to change division to multiplication, and then instead of 2/5, once again I'm flipping it to 5 over 2. Now I can simplify. My 5's cancel out, right? I can divide, or I can cancel these out, and those just turn into 1s. I can cancel out 48 and 2. Those are both divisible by 2, so 48 into 2 is 24. So this whole expression just simplified as 24. So I've got 5 over 2y minus 24 equals x minus 5 squared. Okay, I'm getting closer, right? What do I need to do from here to get x by itself? What's my obstacle? What's in the way? Well, I can't get rid of that negative 5 because that whole term is being squared. So my next step is going to be to take the square root of both sides of the equation. Now at this point, I could have just written my square roots individually over each term, but again, choosing not to, because at this point, I'm not trying to do any further simplification on that left-hand side. So, let's see here. The square root of 5 over 2y minus 24, I'll just leave that all as it is, equals, well, the square root of something squared, those signs cancel each other out, and I'm just left with x minus 5. Now the only other thing I have to do to isolate x is to add 5 to both sides of my equation, right? So finally, I will get that x is equal to, oops, a little low there, let me write it over here, x is equal to the square root of 5/2 y minus 24 plus 5. Notice that my 5 is not under the radical symbol, right? I already had this term I just rewrote it there, and then I added 5 to both sides of the equation, which is why I have that plus 5 right there. So my final answer is x equals the square root of 5 halves y minus 24 plus 5. And that's how I isolated x. All right, let's move forward. The next spell the wizard would like you to undo, okay, so kind of going forward here. The result is the formula r equals root of sine t plus q. And they want us to undo the spell and isolate q. They want us to undo the spell and isolate q. So one thing I want to point out, notice that they tell you the order that things were done. So it started with t, and then it says they took the sine of t, so they had sine t, and then they added q, and then they took the square root all to get r. So it stands to reason that if I do everything in the opposite, it'll help me isolate q. Okay? So that's just kind of a hint. Let's look at a similar example. So once again, this is not what we were just looking at. It's a similar example. Once again, I'm going to try to figure out how to isolate q. So I noticed that the first thing standing in my way is this radical symbol. I can't do anything until I get rid of it. So I'm going to square both sides of my equation. So a negative e squared, well, a negative e times negative e would give me a positive e squared, right? Equals, and then that radical symbol squared just disappears. So I get tangent of x plus q. And now this tangent of x is in my way, so I am going to subtract it from both sides of the equation. Okay? And I end up with e squared minus the tangent of x equals q. Notice that I've isolated q. So this side is kind of ugly. It's not, like, I don't want to have to deal with e squared. I don't want to deal with the tangent of x, and I don't have to because my only goal was to isolate q. So at this point, I'm already done. It was a simple 2 to 3 step algebraic manipulation to get q by itself. All right, let's move forward. So we have another spell. Once again, notice how they tell you that this formula comes about. They say this one starts with y, and then added 6, so they had y plus 6. And then they took the cube root of that, so the cube root of y plus 6, then divided by a, so that's why a is not under that cube root symbol, all to get c. Once again, we're practicing isolating a variable. This time they want us to isolate y. So, once again, I will show you a similar example. Now, again, this is one I just made up. I kind of adjusted the spell accordingly because I wanted you to kind of take note of the way that I can undo the spell kind of by approaching things in the opposite order. So let me show you what I mean. So my spell is c equals the fourth root of y plus 5 over a squared. So I'm going to look at my spell in the reverse order. So they said all to get c. All right, so I've got my c equals. Divide by a squared. So what's the opposite? How can I undo that piece? Well, if I wanted to undo dividing by a squared, I'd have to multiply by a squared, right? So I'm going to multiply both sides of my equation by a squared. This gives me ca squared equals the fourth root of y plus 5. All right, now again, still reading my spell in reverse order. The next thing I see is take the fourth root. So if I wanted to undo taking the fourth root, what would I do? I would multiply, or I would raise my term to the power of 4. Okay, so I'd get ca squared to the fourth power equals my fourth power and my fourth root cancel each other out, and that's just y plus 5. Now, I'm not going to worry about simplifying this just because it's not important, and sometimes we even prefer, like in vertex form, how we left the square intact. We didn't actually solve it out. I'm going to do the same thing here. It's not important to me that I distribute this exponent. Notice now that I'm really close. I'm trying to isolate y. The only thing that's happening to it is it's having 5 added to it, right? Again, reading my spell in reverse order, add 5 is the next thing on my list to get rid of. So if I wanted to undo adding 5, I would subtract 5. So I'm going to subtract 5 from both sides of the equation. I'm going to rewrite it over here so you can see it a little bit better. And I get CA squared to the 4th power minus 5 equals y. All right, so now I have isolated y, and again, notice that I kind of attacked this by doing things in the reverse order of the spell. And not only in the reverse order, but the reverse operation, right? So instead of dividing by a squared, we multiplied. Instead of taking the 4th root, we did the 4th exponent. Instead of adding 5, we subtracted, okay? All right, next up. So once again, we're isolating. Notice that each of our examples has just dealt with a different way of isolating a variable. We dealt with doing it looking at vertex form. We dealt with that funky one that had the trigonometric function in it. Okay, so we're just looking at different scenarios and different ways that functions, or excuse me, variables might appear, and different techniques we might have to do to figure out how to rearrange an equation to isolate a specific variable. Okay, so let's take a look at this spell. So this is the one that appears in your project, m equals 9b over k over 2 plus 3. So notice it said this spell started with k, divided by 2, or multiplied by 1/2, same thing, add 3, raised to the power of negative 1. So what that means is they had k, and then they had k over 2, and then they had k over 2 plus 3. When they raised it to the power of negative 1, it became 1 over k over 2 plus 3. All right. Then multiply by 9b. That's how 9b ended up in the numerator. If I put a 9b right there, all right, that's an equivalent expression. And it says all to get m, so we said equal to m. Now they want us to isolate k. So currently, this thing has solved for m. We need to isolate k. So once again, I'm going to show you a similar example. Notice the similarity in format of my spell or my formula. I'm going to rearrange it to solve for k. All right, so since I've got a little less space, I think I'm going to start up here. So notice once again, the spell started with k multiplied by 1/3 or divided by 3. It's the same thing. Added 9, raised to the power of negative 1, multiplied by 5d, all to get m. So I've got m equals 5d over k over 3 plus 9. All right, so I could do the same thing I did before and kind of tackle this in the reverse order. But this time, I'm just going to kind of look at this one and use my reasoning to figure out what I want to do. As you know, the order in which you do things matters. Like when we were dealing with radicals, we had to make sure that we got rid of the radical before we could really separate anything that was under that radical sign. So here, the first kind of obstacle that I see is this denominator, right? I'm trying to get k by itself, but it's wrapped up in this denominator. So what I'm going to do is I'm going to multiply both sides of the equation by the denominator. Okay? I'm going to take both sides by k over 3 plus 9. So that gives me m times k over 3 plus 9 is equal to 5d times k over 3 plus 9. All right, so again, all I did was multiply both sides of the, I just rewrote that on accident. Notice all I did was rewrite both sides of my equation simplified, and that last little bit I wrote was a mistake. So on the left-hand side, I end up with m multiplied by the denominator. On the right-hand side, my denominator has been canceled out, and I just have 5d. All right. Now I didn't distribute the m, and the reason is that I'm trying to isolate k on the left-hand side of the equation. And m is in my way, so I'm not going to distribute it. What I'm going to do, since m is in my way, is divide both sides of my equation by m. Okay, and I'm going to rewrite this over here now. So m divided by m cancels out. Now I have k over 3 plus 9 is equal to 5d over m. well, what can I take a look at next? Again, trying to isolate k, I see that 9 would be pretty easy to get rid of. I'm going to subtract 9 from both sides of my equation. I'm going to rewrite. I get k over 3 is equal to 5d over m minus 9. Okay. Finally, k is being divided by 3, so the next thing that I can do is multiply both sides of the equation by 3. All right, so on the left-hand side, my 3's cancel out and I'm left with k. On the right-hand side, I'm going to distribute, and that's not an exponent, that's just multiplying by 3. On the right-hand side, I'm going to distribute that 3. So 3 times 5d is 15d, so I've got 15d over m minus 9 times 3 is 27. So to isolate k, I first got rid of that ugly denominator. I moved it through multiplication, and I got my k to the left-hand side of the equation. I divided by m, I subtracted 9, I multiplied by 3. Okay, so I get k equals 15d over m minus 27 as my isolation of k. Finally, I need to summarize the spell-breaking information that we have provided so far in a couple paragraphs and in a couple complete sentences. Explain the method you used to solve each problem above, and then compare and contrast the method. So you don't have to go through and type up every single little thing you did. However, you do need to provide, I would say, maybe 2 to 3 sentence explanation per problem. Okay, it needs to be complete. This prompt says a couple of paragraphs. It's okay if it's not a couple of paragraphs, but I can't imagine that you could explain it in less than at least maybe like 7 or 8 sentences. Okay, because not only do you have to explain the method, you have to compare and contrast them. All right. So again, I'm looking for kind of a full, robust discussion, hitting all the different ways that you approached solving these, and then comparing and contrasting these methods. Hope this helped, guys. I'll see you for the next video.